So this is the first chapter you will learn in Form 4, the beginning in Addmaths. What is function? And before you ask what is function, there is a relation with a function that you need to know. First thing, before you need to know about the function, you need to know what is relation, because they have a relation between a function and a relation. So relation in mathematics, which you have already learned in Form 3, I think Form 2 if I'm not wrong, you have learned 4 types of relation. First, one-to-one relation. One-to-many relation. Many-to-one relation. And lastly, many-to-many relation. What do I mean by this? So for example, I have a domain and I have a codomain. It's an arrow diagram. So let's just say I have a 1 and goes here become 2, 2 becoming 3, 3 becoming 4. So this will be the function, where 1 becoming 2, 2 becoming 3, 3 becoming 4. You can see that it is 1 to 1. This one going to 1. This is mean 1 to 1 relation. What about 1 to many, which means it's the same thing. Well, this to this is f. Oh, by the way, this part you always call x, and this part is fx. It's usually, that's the thing, it can be gx, gx, but mostly we use fx. Same for this, x become here fx. One to many means, for example, 1 becoming 4. The 2 is also becoming 4. That's 1 to many. Sorry, I'm reversed, my bad. The 1 can become 5. 1 to 4 and 1 to 5. So from this 1, it divided into many. Same for 2. 2 it becoming 4 and becoming 6. This is what we call 1 to many. From 1 it become many. There's a lot. What about many to 1? Is the opposite. That's it. So 1 becoming 4, 2 many to 1, right? So 2 becoming 4, 3 becoming 5, 3 becoming 6. Three becoming 4, 3 becoming 4, I don't think so can. 3 becoming 6 can. So from many it goes to one number. So this is called many to one. My bad. 3, it's 1 to many. The relationship is wrong. Oh, I didn't notice that. Thank God. I also can see 3 becoming 4. This is also considered many from here, and the last is 1. Many to many, it's a lot to a lot lah. Same thing. So this one many to many, so it can be here to here. At the same time, it can be here to here. It can be here to here. It's many, it's like a lot. 3 to 6. You can see it's like many to many. 1 to 2, 1 to 6. It's a lot, right? So here's a lot, here's also a lot. So what we call many to many. So there are 4 types of relation: 1 to 1, 1 to many, many to 1, and lastly many to many. So this is relation, but what is function? Function is not all these 4. Function is just some of this. Let me write down. Function is just some of this relation, but not everything. So function, there's only 2 only from this relation, which are 1 to 1 and many to 1. These 2 is only considered function. 2 and 4 is not considered function. Okay, so 1 and 3 only. So far I think I'm not too fast. So if they ask what is function, when one domain, when x to fx is either 1 to 1 or many to 1, that's only function. Many to 1. So that's the definition. Not definition, it's just the understanding lah. What you need to know. Function is like a special relation where each object will has one image only. That's why your ending is 1. So far you only need to know function is just many to 1 and 1 to 1. It's always have the image 1 only. So now let's go to deeper a bit. Function can represent in 3 ways. The most commonly used is arrow diagram, which is what I'm using now. Well, we have here is x, here is fx. We also have another name. This x can also call as object. The fx can also call as image. The x here can also call as domain. Fx can call as codomain. So these are the other names that they will use in exam. Mostly they will use x, fx, object, image, domain, codomain. These are the names that we have. 1 becoming 2, 2 becoming 3, 3 becoming 4, 4 becoming 5. Example So this is one way to represent a function. One is using arrow diagram. Yeah, there's a lot of ways to represent. Arrow diagram is one of the way. Next, we will use a graph method. We will also use a graph. So, but actually the way that they represent it can be a lot. But the main thing, how you will read the graph. So for example, here will be x, here will be fx. 1, 2, 3, 4. 2, 3, 4, 5. So 1 with 2, 2 with 3, 3 with 4, 4 with 5. You will just put a dot or an X. You don't draw a straight line. It's not linear. We are not doing a linear equation. We are doing a function. Okay? So you don't have to draw a straight line. You just have to plot. So this is another way that they can represent a function using a graph. Okay? And the last way is just like a coordinate way. Coordinate. For example, 1, 2, 2, 3, 3, 4, 4, 5 are using the same number. Okay, so this is the coordinate way that they use to represent. Here will be your x, here will be your fx. Your object first, followed by your image. Okay, that's how they will represent. Like another way that they use to represent a function. So these are the three ways that they represent a function. So far, I think I explained what is function. There's only two functions, only you need to know. One to one, many to one. Next, how they will represent the function. They will represent in three ways: arrow diagram, graph, coordinate. These are the three ways that they can represent. And next, I also talk about the diagram, where they will ask about object or domain or X, the image or codomain. This part is image or codomain. This part is object and domain. Don't forget, your fx is always image, your x is always object, domain. Your fx is image and codomain. This is the basic and the understanding you should have. And next, what you should, okay, this thing is very important. You need to know how to identify a domain, codomain, and which I haven't talked about it yet, which is called range. So for example, I have an arrow diagram. Two, three, 4. Exam also might ask this type of question, so it's important. 5, 6, 7, 8. So 2 becoming 5. So this is example. So this is arrow diagram. 3 to 6, 4 to 7. So exam might ask, list the domain. They can ask you this question. Sorry, my handwriting is so ugly. List the domain. And what's the codomain? They also will ask you the range. These are the most common questions they will ask you. So domain, isn't it? I say it's the object or the x. This is x, this is the function f, and here's the fx, or called the image. So domain, there is 2, 3, and 4, right? So that will be a domain, and you have to write in like a curly bracket, something like this. Codomain is the fx, the image part. And the range is the one that give a image, a product, or there's a range for it. So in this case, 5, 6, and 7. If you realize the 8 there has no any object. 2 is the object, and the image you get is 5. 3 is an object, the image you get is a 6. 4 is an object, the image you get is 7. But 8 is in the fx, so it's under the image, but it has no object. When there's no object, there's no way of you getting an image. So the 8 is like how to say, like tak ada guna lah. It like has no function. So think like that. So the only one in the range is 5, 6, and 7. So that will be your answer. So think, when there's no object, it's not in the range. Okay, easy way. Alright, so this is the exam question, and this question was asked not exactly the same number, but they asked this type of question in SPM 2024 paper 1. So don't ignore this type of theoretical question. Based on the pattern that I see from 2021, 2022, 2023, and 2024, what I found is they try to give more theoretical question and they make it complicated. So focus more a bit on theory. At the same time, focus on the problem solving questions, because that's where will give you very high marks. But the main is the problem solving. At the same time, focus the theoretical, understand theoretical questions, because they can easily make complicated from the theory questions. So this question was asked in SPM 2024 paper 1. Not exactly this question, not exactly the same number, but it's similar type of question. The pattern of the question is the same. So don't ignore this type of question. Now let's go to the common exam type of questions. Common exam type of question, they will give, for example, a function, for example fx. Example 2. So they say fx is equals to 3x 4x minus 2, and they also give you x is equals to 5. Find the fx. So this is the exam type of question, but of course they won't ask too directly like this. It's just for starting, so I don't go too difficult here. So I'll be going with a smooth, easier, and then we will try to do a bit difficult question. First, understand. So as I say, x will represent your object, fx will represent your image. Sometimes they do call this domain. They do call this codomain. Don't forget the other name. They also use that. So they give you fx and they give you x is equals to 5. So they ask you to find fx. It's very easy. It's just like substituting. You know your x is equals to 5. So sub your x 5. So when you sub your x 5, remember substitute is very important. So your x there, everything replaced by 5 because they already give you the x is 5. So substitute everything to 5 and then minus 2. The remaining all just copy paste. 3 4 2 3 4 2 and the minus 2. Sorry, the minus, don't forget. But what gives you the mark is the substitution. If you substitute correctly, you will get K1. Okay, substitution is so important. Show your substitution clearly to the examiner. And then it's just easy peasy. Press your calculator, you'll be getting 5/6. So this will be your N1. Okay. Now let's try a bit different. Example 3. Let's just say I have fx equals to x squared minus 3x minus 6. And now I give my x is equals to -2. Find my fx. No matter how complicated the equation, don't worry guys, you have a calculator. That's the advantage for you guys. You just key in your answers, substitute your answers in the calculator, and the calculator will do the remaining job for you. So you don't have to worry. You have your calculator. Make sure for Addmaths your calculator must be in a good condition. So as long you know your x is -2, you just replace all your x with -2 and you're gonna get your answer. All you have to do is press your calculator, or some people just can use your brain. Can, no problem. So -2 squared is 4. -3 times -2, positive 6, and you minus 6, so the answer will be 4. So this is one pattern of exam question. Next, I'm not going to give you fx anymore, but now I'm going to use a theoretical number. So for example, I say given, this will be example 4, given that fx equals to 4x plus 7, and they say find the object when the image is 15. This time around, they didn't say your x, they didn't say your fx, but instead they use a theoretical way to represent a function. So don't worry, they say object, they say image, they say find the object, correct? So what is object? Isn't it I told you just now? Object, there it is x. So they ask you to find the x. What is my x? When the image is 15, what is my image? My fx. So they say my fx is 15. You got your answer. You got your next step already. Yahoo! So you know your fx is 15 and you're gonna find your x. So You got fx15, right? So now what is your fx? Then this, they already give us fx is 4x plus 7. Write that. You see, I didn't change anything. I'm just writing, but in another way that they give us. They say fx is equals to 4x plus 7, right? That's what I'm writing. 4x plus 7. And this is equals to 15. And now you just have to find your x. So what's my x? You take your 15 plus 7, bring here as a minus 7. So this will be equals to 4x, and then x, your 15, you minus 7 will be 8, and your 4x, your x is 8 divided by 2, 4, it's 2. So you got your x. Isn't it what they want? Your x is object and you find already. So another way that they can ask is in using words. Object, domain, codomain. This type of question they use. So this is you need to know for a function. But anyway, I'm not gonna stop here. I need you guys to understand a bit more detail in functions. So what I'm going to do, I'm gonna draw an arrow diagram and gonna give you example. What is actually a function? As I say, function can represent an arrow diagram, graph, or the coordinates. So, for example, this is my x, this is my fx. Sometimes they use g. They can use gx, they can use hx. If h means here will be h, if g means here will be g, if f means here will be f. It depends on the question. They can change according to what they want. So, but the most commonly used is fx. That's why we are just using fx. Okay. So this represents in the function f. So 1, 2, 3, maybe come 2, 3, 4. I'm taking the easiest one. So the story is like this. Now your x is equals to 1, and then sorry, the number is not arranged orderly, my bad. So your function is 1. Think this f, okay, this f, think this is like a bridge. So when the 1 cross the bridge, it becomes 2. Same, the x, when it's 2, it cross the bridge of f, it becoming 3. The 3, it cross the bridge f, becoming 4. Think the function is like a bridge, a jabatan. So when it cross the bridge, it becoming like, if you realize the pattern, it's plusing 1. So when you're 1, you plus 1, you becoming 2. When you're 2, you plus 1, you becoming 3. When you're 3, you plus 1, you becoming 4. If you realize, all this is your fx. 2, 3, 4 is in the fx. And this 1, 2, 3 this is on the x side, isn't it? So I can represent a function equation as fx equals to x plus 1. So this is a function equation. Sometimes we can represent a function equation like this, or we also can use a ratio method. Yeah, a ratio method also is used. This is another way that they represent. It's f ratio to the x, and then the x you plus 1. That's another way that they can represent it. So if you cannot, if let's just say you want to double check, also can. So let's just say when your x is 1, so you check when your x is 1, your x is 1, right? So substitute your x to 1. So when you substitute your x1, you're getting 2. Can you see your 1 here? When it undergo the function of fx plus 1, you becoming 2. So this is how a function works in Addmaths. So I hope it's not so hard to understand. It's not even too hard, right? Yeah, nice. Alright. So I think you're clear with the substitution and what is object, image, domain, codomain, and how can the function represent arrow diagram, graph, coordinates. Next, yes, this is very important too. Next, what you need to know on the function is actually sometimes this one I haven't teach. Okay, let me teach you first. So as I said, function can also represent in the graph. So if they represent a function in a graph, how are you going to identify whether it is a function or not a function? As I said, function is only to one-to-one relation or many-to-one relation, but they can give you many type of relation. So when they give function in a graph, how you identify? Here's a method. So for example, let's just say I have a graph x fx, and I have a graph that going like this. So how you identify whether it's a function or not a function? You have to do a test to identify. So you need to do a test. The test name called vertical line test. So you take any point from the graph. So for example, I take here, and what I have to do, vertical line. So I have to draw a vertical line. And that line, the vertical line, if cut at one point only, then it is a function. If cut at 2 points or more than that, it is not a function. So I give you another graph. So a quadratic curve. So let's just say any part of this graph, choose one point, maybe at this point, and from there you do a vertical line. You realize it cut at 2 points. So if cut at 2 points, then it is not a function. Okay, so this is a function. This is not a function. So this is how you identify function if they give you a graph. And if they give you an arrow diagram, as you know, either it's a one-to-one relation or many-to-one. Only this. Your fx, your codomain or your image always have to be one. Your image cannot be a lot. It can only be one image, but the object can be a lot. Yes, your object can be it's like it can be many. Your object can be many, but the image have to be one. Yeah, you're right. Correct. So this is how you identify function. I think I'm too fast. Am I? Okay, let's do a few type of questions. Okay, we will do a few type of questions. Actually, there's another part that in this chapter, but I don't want to cover it today. Maybe on my next video I will do it with you guys. Okay, that's function that you have to draw a graph. So I don't think so I have a sufficient time to do that graph with the modulus, so we will do a few type of questions to brush up what we learn now. Okay, it's just for your understanding. Now, given that fx equals 3x plus 2 over 2, find the object when the image is 10. So look for the keyword, guys. When you see questions, they say image is 10. They ask you find the object. So what is your object? X. What is the image? Fx. So they ask your x and they give your fx. So you start from the clue they give. For your Addmaths, you have to start from the info they give. So the info they give is this. So start from there. Fx is equals to 10. And what is your fx? There, this is your fx, isn't it? So take your fx equals to 3x plus 2 with 2. And they say this is equals to 10, so equals to 10. You see, I didn't change anything. I just changed the way of I'm writing. I'm not changing anything. I just copy paste what they say. So next is just like your normal mathematics. So do your simple mathematics. Now you're doing Addmaths, so you don't have to do substituting. Bring the 2 up times 10, then you minus 2, then you divide 3. You don't have to show. You're doing Addmaths, so you just can do it everything in your brain or use calculator. and you can get your answer. Okay, so you're probably getting 6. So yeah, maybe I should show. I'm scared that you can't get. So you times this, 10 times 2, 20, then your 3x, your plus 2 bring here, minus 2, so be 18. So then your x times bring here dy, and you get 6. Okay, this is a mathematical way. Right, next, let's go to the next question. If you have any questions so far, by the way, let me know if I'm too fast. So to another question, let's just say given that fx is equals to 5x minus 6 over 2x, find the object. When image is 4. So this time they say find the object. It's the same thing, and they say image is 4. So they say your fx is 4, isn't it? Image represents fx. I think from the beginning of the video I'm keep saying this. Never mind, let me say until you understand and you remember. Let this thing stick in your head. And your object is x, because they keep on using the same word, so I don't want you to forget that and don't get confused. And they say fx is 4, find the object. So find the object means you're looking for your x. So you know your fx is 4, and you also give you what is your fx. It's 5x minus 6 over 2x. So another way of I'm writing the fx is this way, and I know this is equals to 4. My fx is equals to 4, and now I need to find my x. So you just have to do your simple basic maths. Your 2x you bring here, 4 you times with 2x, so you get 8x. And yeah, your 6 bring there, your 8x minus here, and you'll be minus 3x equals 6. Your x, 6 divided with negative 3, and lastly your x equals to negative 2. Your 5 minus 8x is negative 3x. So done, you get your x. Guys, trust me, this is not so hard. They won't. For function, it's very hard to give you a K-bar question, but somehow they still can give you a K-bar question. But first, understand the basics, how you do the questions. Keep on practicing. Understand first. Okay, that's the important thing that you should have when you do maths. Understand and then you do. So I hope you're okay with this. We will do another one more question. So this will help your understanding. So given that fx equals to 4x minus 2 over x minus 2, and find the object. When image is 6. So find the object. Image is 6, and they give you this. fx. These are the clues that they give you. Use them wisely. Okay, so object is x, image is fx. So they say fx is 6. And what's the fx for x minus 2 over x minus 2? And this will be equals to your 6. Find your x. So for x minus 2. So this x minus 2, the bottom one, the entire thing you bring up. So you times everything. And then you have to open bracket 6 times x, 6x. 6 times negative 2, negative 12. 4x minus 2. You see, I didn't do anything. I'm just expanding. I'm just doing the normal mathematic. So, and then bring your x one side, the normal numbers one side. So the 4x I bring here, so 6x minus 4x, and the negative 12 I bring here. So negative 12 bring here become positive 12 minus 2. So 6x minus 4x is 2x. 12 minus 2 is 10. So my x will be 10 divided by 2. So it's 5. Done. Okay, so far. Last question. Given that fx is equals to 2x plus 4, find the object when function f mapped onto itself. Remember this keyword, mapped onto itself or into itself, whatever. The verb map itself. What does this mean? Which means, let me explain you using the arrow diagram. So I have an arrow diagram. Let me bring this closer. Map onto itself means your x and your fx. For example, I have a 1 and I cross the bridge f, it will be still 1. It just map into itself back. Can you see the idea? Can you get the idea? If let's just say here is 10, here be 10, it just map back to itself. So it just map back to itself. So there's no any addition, subtraction, division or multiplication, nothing. It's just itself. You didn't plus or minus, nothing. If here is m, here also be m. That's mean by map onto itself. Which mean here also x, here also x. Here 10, here also 10. So from this I can actually come to a conclusion. My fx, no matter what, when it map onto itself, your fx will always equals to your x. Isn't it? Because you see, your fx is 1, your x is 1. Your 10, your x is 10. Your fx is m, x is also m. So I can get the conclusion where I can say my function fx and the x because they map onto itself, I can generate an equation called fx equals to x. So this would be my key or a clue for my next step for workings. So I know when they say map onto itself, no matter what, my fx is always equals to x. It will be the same thing. Correct or not? If here is f10, here will be 10. Here is correct or not? Because you see, when my x is 1, my fx will be 1. My x is 10, my fx will be 10. When my f here is xm, my fx is m. So when my fx is the x is x, here will be x, isn't it? Because they map onto itself. So no matter what, it will be the same. So what is my fx? There they already give us 2x plus 4. So I can say 2x plus 4 is equals to x. And now just play with your x. Bring your x one side, your numbers one side. So 2x minus x plus 4, bring that minus 4. 2x minus x, x. So x is equals to negative 4. Done. If you're not sure with your answer, you can double check. So now substitute your x into the equation. So what is your fx? 2x plus 4. Just now only we do this type of question a lot. So your x is negative 4 and you plus 4. So if this equation is correct, I should get back my x negative 4. Isn't it? So 2 times negative 4 is negative 8 plus 4. And here you go, you press your calculator. I'm getting negative 4. So f negative 4, I'm getting negative 4. Can you see? It's the same. Because they map onto itself. That means no matter what, your fx will be equals to x. No matter what, it will be the same. Because they say map onto itself. Okay, so I think I covered quite a lot in function just in a while. That's a lot. So I think it's approximately 1 hour. So now I don't go to the I'm not doing the graph part here yet because it's quite a lot, and I'll be doing on my next video. So for now, before I end, let's just do a quick summary, briefly I will explain back what I just taught in this 1 hour. So first thing, a brief explanation, like a summary before we end. Function. Remember I say function is a relation, but relation is not a function. You have 4 types of relation: one to one, one to many, many to one, many to many. But function is not all of them, it's just 2 only. What are the 2? One to one, many to one. where if you see an arrow diagram, they are like this. It's just 1 to 1. If many to 1, it will be something like this. From a lot, many, and it just goes to one place, one image. That's many to 1. So this is how they represent in arrow diagram. So this is function. And remember, I just now told you function can, if they give you a graph, you actually can identify whether it's a function or not through vertical line test, isn't it? So for example, I give you a graph. Something like this, and you just take one point. So just say take this point and do vertical line, and if you realize it just cut at 1 point. So a function means it cut at 1 point. So then it's a function. You have to do vertical line test if they give you a graph. And I also got to teach you the arrow diagram and what are the other names that they will use. For example, it's too big. So x, fx, they also call this x, fx. They also call this as object, image. Besides that, they also call this domain. They also call this codomain. It's another way that they call this. Don't forget that. And for example, I have 1, 2, 3, 4, 5, 6, 7, 8. 1 related with 5, 2 with 6, 3 with 7, and 4 with 7 maybe. So what is your domain if they ask you? Remember, do in a curly bracket whatever your x is your domain. 1, 2, 3, 4. And if they ask you codomain, whatever in your codomain, here 5, 6, 7, 8. But one thing, range is whatever has a pair, object and image, must have these two. You cannot stand just by image only, so that is not considered in a range. So the range will be 5, 6, 7, because the 8 here has no object, so there is no partner. You don't take that. So the range is 5, 6, 7. That's the difference, huh? Don't get confused with codomain and range. And what else we covered today? Quite a lot. Function. Remember, we also can represent this in a form of graph. Remember I told you, one arrow diagram, second using graph, but we don't draw a line, we just plot. My bad. Your x-axis is always a x, here's fx, 1 2 3 4 5 6 7 8. So 1 with 5, 2 with 6, 3 with 7, 4 with 8. So you just use a plot, a dot, or sometimes X. Just plot lah. So this is another way that you represent, and also the coordinate. So you can say 1 5 2 6. This is another way they used to represent. Okay, 2 6 3 7 4 8. Yeah, this way also they use 4 8. Let me write this. So this way is a coordinate, graph, arrow diagram, and what else we do? Graph, this. Oh, one more thing, last one that we just now only do, map onto itself. But this is the first way, second way, the third way. And then don't forget to close them. I forgot this. Okay, and the map onto itself is the last part that we covered for today, isn't it? So map onto itself, your object is always same as your image. No matter what, it will be the same. If A, B, C, so it's just getting the same outcome. It's just the same thing. That's why we say it's mapped onto itself. When we say that means the object is equals to image, and we automatically can represent can form or generate this equation. This equation they don't give you, but they, instead of giving you this equation, they say map onto itself. So this is all you should know for today's